Toothpaste is a gel dentifrice that is utilized by many for oral hygiene. It acts as an abrasive that functions in removing dental plaque and food residue from the teeth, aids in suppressing halitosis or bad breath, and prevents tooth decay using active ingredients which is mainly fluoride. The main principle utilized in the manufacturing of toothpaste is mixing. The ingredients of a toothpaste are subjected to mixers where temperature and humidity are closely monitored. The composition of toothpaste is sorbitol, calcium carbonate slurry, carboxymethyl cellulose thickener, preservatives, methylparaben, sodium saccharin, sodium monofluorophosphate, sodium silicate, sodium laurate sulfate, and flavor. The presented picture is the process flow diagram for the manufacture of toothpaste. The process includes mixing the ingredients and the packaging of the aluminum tubes. Also presented here is the list of the waste that are discharged by the plant. Just like any other industrial plants, the toothpaste plant also produces air pollutants, wastewater, and solid waste that can be a possible threat to human health and to the ecosystem. Pertaining to the process flow diagram, the water quality parameters affected in the wastewater are evaluated. These include total dissolved solids due to the salts dissolved in the mixture, total suspended solids due to the presence of colloidal substances in the slurry formed, and then color, which implies the presence of dissolved solids, turbidity, which is mainly caused by the abundance of suspended or colloidal substances, and then we have hardness, which indicates the presence of calcium ion due to the dissociation of the calcium carbonate, and also the alkalinity, which is mainly due to the presence of the carbonate ions in the wastewater. As shown by the chemical reaction, calcium carbonate dissociates to calcium ion and carbonate ion, which contribute to hardness and alkalinity respectively. Furthermore, carbonate ion can react to an acid to form a bicarbonate ion, which also contributes to the alkalinity of the wastewater. The process flow diagram also indicated the air pollutants emitted by the plant that can have deleterious effect on the environment. The aforementioned air pollutants include carbon dioxide, nitrogen oxides, sulfur oxides, carbon monoxide, ozone, VOC or the volatile organic compounds, and particulate matter. Carbon dioxide is a result of the combustion of hydrocarbon. When incomplete combustion occurs, carbon monoxide is formed. Ozone can react with nitrogen oxide to form nitrogen dioxide. When nitrogen dioxide and volatile organic compounds react in the presence of sunlight, they form photochemical smog, a significant form of air pollution, especially in the summer. Nitrogen dioxide can be broken down by sunlight to form nitric oxide and an oxygen radical. Oxygen radicals can then react with atmospheric oxygen to form ozone. Ozone is consumed by nitric oxide to produce nitrogen dioxide and oxygen. Harmful products such as PAN or peroxyacetyl nitrate are produced by reactions of nitrogen dioxide with various hydrocarbons, which are compounds made from carbon, hydrogen, and other substances. The main source of these hydrocarbons is the volatile organic compounds or the VOCs. Similarly, oxygenated organic and inorganic compounds react with nitric oxide to form more nitrogen oxides. As shown by the reaction, SOx are produced from the burning of fuels which contain less than 1% of inorganic sulfides and organic sulfur. The solid waste produced from the manufacturing process are the packaging material of the chemicals, the damaged and rejected aluminum tubes, the damaged and rejected plastic caps, and the cartons. The monitoring of the air pollutants emitted by the plant is for the plant to abide to Republic Act 8749 or the Clean Air Act.
This is the wastewater treatment design of a process flow diagram in manufacturing whitening toothpaste. The incoming wastewater from the plant is subjected to preliminary treatment, which is passing through a bar screen. The floating solids here will be removed and directly disposed in the landfill, while the able solids are passed through a primary settling tank. The sludge produced will go into the sludge digester to where the destruction of pathogens happens and to make the sludge dry easier. The temperature is maintained at 30 to 35 degrees Celsius, and after 20 to 30 days, the well-digested sludge is passed to a drying bed, leaving some raw sludge in the digester in order to let the incoming adopt. The secondary treatment begins when the primary effluent goes to an aeration tank. The biological process takes place here, where a liquid is held in order to increase the amount of air within it, at which the high oxygen levels increase the speed, and then the water is cleaned. The secondary effluent will then go to another settling tank, and here the sludge is returned into digester, and the resulting water will now undergo tertiary treatment. The treated water is divided into four classes: Classes A, B, C, and D. Class A undergoes several stages of filtering and disinfection with chlorine. This type of water can be used as potable and for agricultural and domestic uses. Meanwhile, classes B, C, and D are used for agriculture with several restrictions, since it directly came from the secondary settling tank that didn't undergo any disinfection. This wastewater treatment is designed in order to abide in the Republic Act 9275, also known as Philippine Clean Water Act, that quotes, "The state shall pursue a policy of economic growth in a manner consistent with the protection, preservation, and revival of the quality of our fresh, brackish, and marine waters."
There had been campaigns with regards to putting a full stop on the usage of plastics despite its vast application in packaging. Plastics are seen by many industries as a burden as the solid wastes are difficult to recycle. The properties of the plastic deteriorates after the recycling process. However, designing an innovation for the recycling of this non-biodegradable waste enables sustainability by reducing the environmental cost of waste disposal. Effective recycling leads to an overall reduction of waste, cost, and energy consumption, effectively reducing greenhouse gas emissions and an overall low carbon footprint for the industry. Disposal of post-consumer and industrial waste laminates is a critical issue for industries that utilize packaging materials. Recycling has been the best alternative to address this issue, although conversely, it is a challenge for industries to recycle aluminum barrier laminated waste. Recycling of laminates is difficult due to the following barriers. The first one is the compatibilization of polyethylene terephthalate, polyethylene, and polypropylene. And the second one is the presence of inks in case of printed laminates which may affect properties of recycled compounds. The third one is the presence of aluminum in case of metallized laminates. The fourth one is the presence of various adhesives for binding different layers in laminates. And lastly, difficulty in handling of laminates. The solid waste that were put in the materials recovery facility are the packaging material of the chemicals, the cartons, plastic cup, and the aluminum barrier laminated tube. The presented process is the design of materials recovery facility. The process includes collection of the solid waste, washing and shredding of the waste, agglomeration of waste, extrusion to remove volatile organic compounds, and conversion into pellets, where pellets are made into a new usable material. The pulping materials, which is the cartons, are taken through a comprehensive filtering process to get rid of all the foreign materials present, as well as impurities such as strings, tape, or glue. The pulp further goes into a chamber where contaminants like plastics and metal staples are removed through a centrifuge-like process. Plastics float on top while the heavy metal staples fall to the bottom, after which they are eliminated. The next process, the inking, involves putting the pulp in a flotation device made up of chemicals that takes away any form of dyes or ink via a series of filtering and screening. This step is also called the cleaning process as it cleans the pulp thoroughly to ensure it is ready for the final processing stage. The design of the materials recovery facility is for the plant to abide to the Republic Act No. 9003, also known as Ecological Solid Waste Management Act, which ensures the proper segregation, collection, transport, storage, treatment, and disposal of the solid waste through the formulation and adoption of the best environmental practice in ecological waste management, excluding incineration.